So this question says, let u equal 2 minus 1, 3, and v equal 3 minus 2, 1. Find numbers x and y such that xu plus yv is equal to 1 minus 2 minus 9. Let's just go ahead and write this out all as matrices. So we have u is equal to 2 minus 1, 3. V is equal to 3 minus 2, 1. And we have xu plus yv is equal to 1 minus 2 minus 9. So again, if we take this and we rewrite it, we get 2, negative 1, 3, all of this multiplied by x, plus y multiplied by 3 minus 2, 1, and all of this is going to equal 1 minus 2 minus 9. So we can again rewrite it. So we're going to take our x's and we're going to put them into this whole matrix, and our y's same thing. So now we have 2x plus 3y is equal to 1. Then we have negative x, because negative x here is the second row, plus negative 2y, so negative 2y is equal to negative 2. And then we have 3x plus y is equal to negative 9. And we are asked to find x, and we're asked to find y. Now hopefully this should be looking awfully similar to what we've done before. We are just going to be solving this using Gauss-Jordan elimination. So we can put this system of linear equations into augmented matrix form. So we have 2, 3, 1, minus 1, minus 2, minus 2, 3, 1, minus 9. If we remember about our Gauss-Jordan elimination, the first thing we are going to do is take this first number here, turn it into a 1, and then we are going to zero out the entire column. Second thing is we're going to take this negative 2, turn it into a 1, and we are going to zero out the entire column. So it's important to see here that we only have two variables. We only have x and y, but we have three equations. So if there is a solution, it means that this entire bottom row has to be full of zeros, because this will be a 0, this will be a 0, but if this number here isn't a 0, it means that there are no solutions to this set of linear equations. Let's go ahead and start then. We are going to do new row 1 is equal to the old row 1 times 1/2, or you could just say 1/2 times row 1, because we want the 2 to become a 1. So what we get here is 2 divided by 2 is 1, 3 divided by 2 is 3/2, 1 divided by 2 is 1/2. Nothing changes for the rest, so we have negative 1, negative 2, negative 2, 3, 1, negative 9. So now that we have this, we are going to zero out this entire column. So our new row 2 is equal to our old row 2 plus row 1, because negative 1 plus 1 is equal to 0. And our new row 3 is going to be equal to our old row 3 minus 3 times row 1. So we use this 1, multiply it by 3, 3 minus 3 is 0. Let's write our new augmented matrix out. So our new row 2 is equal to our old row 2 plus our old row 1. Nothing happens to row 1, so it stays the same. Now for row 2, we do our old row 2 plus row 1. Here we have negative 1 plus 1, which is 0. Now we have negative 2 plus 3/2, which is negative 1/2. And we have negative 2 plus 1/2, which is negative 3/2. Lastly, we have our row 3, which is our old row 3 minus 3 times row 1. So 3 minus 3 is 0. 1 minus 3 over 2 is equal to negative 7.5, or sorry, negative 7/2. I used my calculator for this, did not do it in my head. So negative 7 out of 2.
And then our last one we have negative 9 minus 3 times 1 half, and negative 9 minus 3 halves is negative 10 and a half.
The next thing we do is we take this number here, we turn it into 1. So to do that, we're going to multiply it by negative 2, because negative 1 half times negative 2 is 1. So let's see, our new row 2 is equal to negative 2 times our old row 2, and we get, nothing happens to row 1, so 1, 3 halves, 1 half, 0 times negative 2 is 0, negative 1 half times negative 2 is 1, negative 3 halves times negative 2 is 3, and nothing happens here, so 0, negative 7 halves, negative 10 and a half. That's our last step here. We are going to zero out this entire column. So to do that, our new row 1 is equal to our old row 1 minus row 2 times 3 half. Could have rewritten this as row 1 minus 3 halves row 2. So if we multiply 1 by 3 halves, and we do 3 halves minus 3 halves, we get 0. And then our new row 3 is going to be our old row 3 minus 7 halves, actually plus 7 halves row 2, because here we have negative 7 halves plus 7 halves is going to be equal to 0. And our final matrix is going to be 1, 0, because 3 halves minus 3 halves is 0. Then we have 3 times 3 halves, and then we have 1 half minus the answer to that. I just used my calculator and I got negative 4. And then for this row, I don't do anything, so I have 1, 0, 1, 3. And here I have 0, 0, because negative 7 half plus 7 halves is 0. Then again, I'm using my calculator for this. I have negative 10 and a half, which is row 3, plus 7 and a half, 7 halves times 3, and my answer is 0, which means that there is a solution, and we figure that out. X is equal to negative 4, because this is x, this is y. Y is equal to 3. So now there's actually a second part to this question that we're going to go over next.